Hello, welcome back, and it gives me great pleasure to introduce PTC, David Hughes and Roy Clarke. They're going to be speaking on the power of AI within the shipbuilding engineering product lifecycle. So, gentlemen, the floor is all yours.
Great, thanks, Jonathan. Thanks very much, everybody, for stopping on. As Jonathan says, my name is Dave Hughes. I work for a company called PTC, and I'm joined today by my colleague Roy Clarke, who will introduce himself a little later in the session when he talks us through a demonstration that we prepared. So we've decided today to focus our topic on, along with other sessions, I guess, today, on the role of artificial intelligence and the way it's starting to increasingly have a role within, in this particular case, a product lifecycle. And we're going to talk a little bit about how PTC is integrating these capabilities into our established digital tool sets. So for those of you that don't know PTC necessarily, so we've been delivering software solutions into this space now for some 30 plus years. So we sort of we deliver into multiple segments or verticals in the industrial space. And we've got solutions that span CAD, PLM, ALM, IoT, and the SLM domains. So let's dive into the presentation, if I can get the slides to work, which is interesting. There we go. Okay, so let's look at this interesting quote from the chief engineer of the US Navy, which references the fact that for decades, digital tools, data, analytics lived on the margins of shipbuilding, and they tended to support life cycle artifacts after these decisions had already been made, obviously quite late in the life cycle. But today, these elements, we're seeing that they're moving more to the center of how ships are designed, built and sustained over decades of service. And so they're no longer optional accelerators, they're becoming really the backbone of the shipbuilding life cycle itself. And that shift matters because shipbuilding is facing pressures never seen before. It's probably fair to say, such as increasing platform complexity, tighter delivery timelines, constrained workforces, and the need to outpace rapidly evolving operational requirements. And these demands themselves cannot be met by doing the same things, you might say, slightly faster. They can only really be met by doing things fundamentally different. Digital transformation itself isn't about just new software, just as it isn't about artificial intelligence for automation for its own sake, but it's about allowing decisions to be made earlier in the life cycle with better information and with confidence that what is designed can actually be built, sustained, and delivered at scale. So as a company engaged in delivering software solutions into this market, we're going to focus the session, as I say, on PTC's core solutions. So I'm not on the core solutions themselves, but rather on how we're integrating those AI capabilities over the top into the established solutions to assist in this particular case, in the shipbuilding sector. And you'll have to forgive me because I'm having trouble trying to get the slides to move. There we go. Okay. So let's have a little look at the challenges. And some of these, I think they have come up before on some of the sessions, but again, just to set this context, the challenges that are faced in the shipbuilding industry today. So across the industry, we're seeing unprecedented pressure coming from multiple directions, internal and external forces. And what's striking is not maybe just the scale of these pressures, but how interconnected they've become. And as the first point here suggests, environmental and regulatory pressures are rapidly intensifying. Sustainability is no longer a future ambition, and it's actually a design constraint today. Even things like emissions targets, compliance requirements, and reporting obligations are shaping decisions earlier and earlier in the life cycle. And once those decisions are made, clearly they're incredibly difficult and expensive to back out of. And the cost of getting it wrong has never been higher than we see today. And once we lay on top of that rising material and production costs, things like inflation, supply chain disruption, and constrained availability are making these cost predictions incredibly difficult to do. And so budgets that once felt solid are now moving targets. And late changes ripple through schedules and margins faster than ever before. So the margin for error is constantly shrinking. The need for organizations to launch digital transformation initiatives to modernize brings its own pressures. we talk about it a lot, digital transformation at PTC, but we also understand how difficult that is for our customers to start to implement. And technologies like AI, automation, digital twins, and predictive maintenance are no longer experimental. We all understand the potential, yet many organizations, as I say, are still struggling to move beyond pilots and point solutions. The promise is speed and insight, but the reality often feels more complex than expected. Then moving to the right, there's the subject of talent and workforce transformation. So the industrial base obviously is clearly really important to ensure we keep this capacity. And we've got a generation of deeply experienced professionals that are now looking to retire. And with them, going out the door is decades of knowledge. So at the same time, new talent expects digital tools, modern workflows, modern ways of working that maybe haven't been there in the past. So the challenge isn't just about hiring, it's transferring knowledge, reskilling at scale, and enabling people to be effective more sooner. And finally, on the right-hand side, there's market volatility and obviously the ever-present geopolitical uncertainty today. So shipbuilding hasn't always operated on long life cycles, even if the markets, to correct myself, shipbuilding has always operated on long life cycles, even if the markets in which they operate don't. These demands fluctuate, missions and objectives shift, and geopolitical realities evolve. Yet vessels, as we've heard already today, are still being designed years before they ever touch the water. So the tension between long-term commitments and short-term uncertainty is one of the defining challenges of our time. So the response to these challenges obviously isn't technology or AI alone. Rather, it lies in rethinking the product lifecycle itself, treating it as a connected digital continuum rather than a series of handoffs. One where data flows seamlessly from concept to design, from build to sustainment, and where decisions are informed earlier, trade-offs are visible sooner, and change becomes manageable instead of disruptive. So what's PTC trying to do about this? So we're part of a large software industry, obviously trying to develop products that service this market or this industry. So let's sort of shift to what we're trying to do in response to these challenges to deliver some cutting-edge capabilities across the life cycle, which we've been doing for many years. So clearly what we're doing is being augmented by what AI can now offer us and other software companies alike. So at PTC, we believe the most effective way of unlocking the value of product data is with what we call the intelligent product lifecycle. So this strategy is derived to help organizations build structured product data foundations in engineering and extending the value of that data across the enterprise. These foundations can then also become the backbone of AI-driven transformation across organizations. Typically, processes and tools being used across engineering tend to be siloed and fractured, and this has been the case for many a year. Our goal is to drive collaboration and traceability across these processes, including a more unified approach to software and hardware development. Because software defines physical products more than ever before, bringing the software and hardware development processes closer together, we believe, through a shared and associative view of product data is perhaps the most important part of this strategy. And because the product lifecycle involves many enterprise systems, another pillar of that strategy is to make it easier to integrate across the enterprise using various integration technologies, which could be API frameworks and other technologies alike. Product data foundations also then serve as the backbone of AI-driven transformation in organizations. And we heard this earlier on with one of the speakers saying, until these foundations are in place, it's very difficult to overlay AI capability on top of that foundation itself isn't already in place and working effectively. So we envision an ecosystem of specialized AI systems and agents that work across this life cycle. These could be traceability agents, change management agents, or field service agents, all with progressive levels of maturity and functionality. These agents will allow companies to interrogate information from the product data foundation and will help distribute and contextualize it across other parts of the business through systems like ERP, MES, and field service management. This will allow teams to focus on higher priority tasks that move the business forward. So what's our vision for trying to help customers to implement AI. So when we look at our vision for facilitating customer outcomes in an AI-driven world, we'd like to frame this as a journey that moves from the individual to the enterprise and ultimately to how entire markets develop products. So as the first pillar on the slide suggests, our goal is to turbocharge workers by providing instant access to information, allowing them to engage with it through natural language, and enabling AI to take on repetitive or well-defined tasks, such as searching, summarizing, or executing specific steps in a workflow. So the goal here is twofold: to increase productivity, to expand access to knowledge. We currently believe that roughly 80% of AI use cases today fall into this advisor category. But over time, this should typically evolve towards agent-based experiences where AI works on your behalf. We move from human in the loop basically to human on the loop, so overseeing. So the second pillar is about raising the enterprise IQ by accelerating the digital transformation journey and efficiently connecting systems and data to realize the promise of the digital thread that we hear so much about. But what's changing here is the rise of what's called agentic AI. So agents can now act as flexible messengers between systems, exposing data, coordinating actions, and reducing the friction caused by rigid integrations of the past. So the first impact we see here is faster insights and decision making, and silos start to break down, collaboration improves, and teams move faster. A great example of this is change management and just the change impact analysis that takes an enormous amount of time, and we'll come back to this a bit later with a demonstration that Roy will show. But the third pillar here is more aspirational, and it's where the long-term transformation lies. This is about rethinking how products are developed. We see AI agents working consecutively across the life cycle, turning linear waterfall type processes into more iterative loops that we'd like to see, so that we can act quicker, make decisions quicker with better informed decision taking off the information that we can surface. So we don't see AI obviously as replacing people, but we rather see it as augmenting the people that we have. And in PLM, for example, AI can automate routine work, but its real power is in delivering better insights and giving people back time to focus on higher value decisions. So the human in the loop remains absolutely essential. So our strategy is focused on empowering individuals, scaling intelligence across the enterprise, and ultimately transforming how evolving products are designed, built, and maintained. Okay, so how do we typically approach this with companies that we deal with? So when organizations talk about introducing AI, as I said earlier, the biggest challenge isn't the technology, it's how to adopt it responsibly, how to be sure that this actually is going to add value to an organization. So we tend to take these three stages that you see on the slide here. So the first stage is around advise, and this is clearly the lowest risk, highest trust way to introduce artificial intelligence in the first instance. So at this stage, AI agents act as advisors, answering questions, summarizing content, and retrieving information from approved sources. So at this stage, nothing is automated, no actions are taken as humans remain fully in control. This is important organizationally because it builds acceptance and trust within AI. It helps employees learn how to work with it and establishes governance around data access, security, and accuracy. Once an organization is comfortable here, the next stage is to move to assist. And this is where AI starts participating actually inside workflows, but still with humans firmly in the loop. AI agents at this point might draft content, prepare recommendations, pre-populate systems, or trigger initial steps, but people review, approve, and still remain accountable. This stage is critical because it demonstrates real productivity gains, allowing teams to validate AI outputs in context, creates operational guardrails before potentially moving to full automation. Only after trust and experience is established at this stage can we move on to the truly automate stage. And at this stage, AI enables end-to-end workflows with minimal to no human intervention. Decisions and actions are handled automatically based on defined policies and models. Humans stay involved, but only really at the governance and exception and optimization levels. So we believe by moving through this framework from advise to assist to automate, organizations are able to build trust in AI, reduce associated risk, and create measurable value at every step of this framework. So just by way of introducing the demonstration that Roy is going to show us. As I said earlier, what we're trying to do at PTC is overlay capability on established AI capability of established capability we have, and in this particular case, it's within our PLM solution. And we'll also look at our ALM solution, or requirements management solution, Codebeamer. So we're going to look at engineering change management, and more specifically, how AI can bring value. So, and we're currently at PTC developing how to deploy semi-autonomous agents to optimize processes between engineering and manufacturing. So change typically starts with a problem report. We can deploy a PR agent to help collect and collate information. So this agent then collects content such as emails, Teams chats, but also collects data from the PLM environment itself. And the human in the loop obviously discerns what to do with that content. The change coordinator then looks at impacted items for this change. And this initial impact assessment involves interrogating the PLM system by the agent to ascertain further information, and can extend further into the requirements management domain in this particular case to ascertain what the impact might also be on those requirements and how those requirements could be affected. Obviously, further downstream, also the agent can interact with ERP to look at cost and inventory impacts related to affected items already gathered. And of course, any enterprise system can be in scope for this. It's not just relatable to the three that we're talking about here. So the use of agentic AI can significantly drive consistency across an organization and accelerate timelines, in this particular case within the change process, but across the complete life cycle, from design, build, and into the field. So with that, let's have a look at how this relates to PLM and requirements management, and I'll hand over to my colleague, Roy.
Thank you, Dave. Just sharing the screen. Hopefully that's coming through okay. Is that okay, Dave?
Yep.
Okay, great. Hello, everyone. My name's Roy Clarke. I'm a solutions architect at PTC. I'm just going to give a very brief demonstration at what Dave was talking about in terms of establishing a strong product data foundation, and then using AI to kind of amplify the value of that data and scale expertise out. So we've got a product structure here. We're actually looking at a manufacturing bill of material for a mooring winch. And associated to this product design in Windchill PLM system, we also have a process plan, or a bill of process. So this is in this case, the steps required to assemble this particular product. So in PLM, we're establishing what to build and how to build it. Early on in the life cycle, we also as well have requirements management processes to go through. So this is Codebeamer, ALM solution. And within this kind of mooring winch project you see here, we have a number of trackers which can cover things like hardware requirements, software requirements, FMEA, etc. And these are being used not just to just refine the requirements, but also capture testing and verification procedures once the product's been built as well. So how do we pull all this together into the world of AI? I'm just sharing here just a third-party AI tool called Clarke Desktop. This is not a PTC product. And, I could ask this a question such as, why is the grass green? And it will go to its large language model and it will tell me. But what we're interested in is finding out about product information and requirements management information, etc. So a question from a change management perspective, what would be the manufacturing impact on replacing that particular part? So I'll ask that question of the AI, and you will see that it's going to start reasoning about what it needs to do. It says, right, I need to get information from Windchill here to look at the product structures, where used information, related process information. What's happening under the hood here is that we at PTC are using an open standard called Model Context Protocol. That's MCP. And MCP is a standard way of interfacing AI tools to our business systems, to our ERP systems, our PLM systems, our MES systems, for example. And so we're really using the large language model. We're not training it with our product data. We're using it as a natural language engine for understanding our question, but also as a reasoning engine as well to work out what to do with that question. So, to answer what's the manufacturing impact assessment, it's gone into Windchill and found some part information. It's worked out that it's used in a couple of higher level assemblies, one of them being an M-bomb. And that M-bomb is related to a bill of process where we have the operation here where that part is consumed, kind of required skill levels, the work center, process materials, and then finally starting to provide a manufacturing impact summary from all the information it's found. And MCP has basically enabled this, where we have wrappers on top of our systems, such as Windchill and such as Codebeamer, to enable the AI to talk to those systems. So we could further refine our query, for example. So, and what about requirements impact? And again, by submitting that question into the AI, again, it's using MCP to think about what tools it's got available to itself. It realizes there's a tool called Codebeamer, which deals with requirements. So it's now going to Codebeamer, looking at what projects are available. In those projects, there'll be various trackers for doing things like hardware and software requirements, FMEA, as we mentioned. And again, applying that reasoning to eventually give us a detailed requirements breakdown. I'm very aware of time. I think, Dave, that shows the main kind of aspects we wanted to get through. Should we open it up to questions?
Sorry, David, I think your sound's not coming through on the microphone.
Yeah, sorry. I said while that's thinking, we could open up to questions, and that will come back on the screen with its findings, hopefully, before the end of the session.
Okay. Great, thank you. Brilliant. Yes, very interesting to see the work you're doing there. And we'll have a quick look at the findings indeed. One of the questions I had was, like, given the concerns then regarding security, which is always an issue when using AI, how are you then delivering AI capability whilst maintaining a high level of security of PTC products that you're known for?
Yeah, so I mean, all the business systems we deal with, so the PTC products such as Windchill and Codebeamer, but ERP systems, other PLM systems, they all have their own access control model. So they all protect their own data based on the authorization rules they govern. With the AI here, if I can say it properly, we're not publishing the data out into some large engine for training the large language model. The LLM is being used as a reasoning engine, and it's basically calling the APIs of the systems to get the data that's been asked for when it needs to, and then reason on that data to provide a response back. So we very much feel that still the responsibility for the access controls is in the source systems that host the data. And then there's a question for companies in terms of the large language models themselves. Do they run in the cloud to get the compute power? Do they need to be on premise because of security requirements? Okay,
excellent. And then I suppose then, does the incorporation of AI then mean a greater overhead for IT organizations as it relates to like typical digital engineering solutions?
I would say there's a certain architectural aspect to it. So if you're using something like MCP, Model Context Protocol, as we saw in the demonstration, you need to provide basically MCP wrappers across your existing systems to tie in the AI tool to the business system. So what we want to avoid is having lots of point-to-point integrations, which is something, from an integration perspective, software companies been looking to avoid for years and years. It's nothing new. This is just with a kind of an AI context. So we do need to just think about the architecture and make use of these standard protocols to accelerate the adoption of these technologies.
Okay. I guess also, Jonathan, where there probably is an overhead that's unique to sort of the defense sector is around the use of large language models themselves, because clearly in a commercial setting or less sensitive setting, you could use LLMs that are currently available somewhere else on the internet. Obviously, that isn't the case with defense for obvious reasons. So there's obviously an overhead associated to maintaining your own LLMs on site to ensure that you can sort of ensure your data learns against those large language models as well. But of course, that then has to be taken care of by an administrative team within that organization.
Okay, great. We have a question from the audience, Lucas at Aglo Eastern. He's asked, did you prepare, configure or build barriers in the LMM you have used, or is this just to demo the use of MCP and you will later integrate this into your PTC product?
Yeah, so this was to demonstrate the use of MCP, and this is the technologies that we're doing. So we're embedding a number of agents directly within our enterprise systems. So things like kind of searching through documentation, things like part classification and reuse agents in PLM, requirements authoring agents in ALM, for example. I think it's a very good question, Lucas. The guardrails do need to be there, and I read a number of things kind of out there in the industry about, you know, the need to own your own LLM as a business and scale it over time. So in the industries we work in, when you consider regulatory requirements, health and safety especially, these guardrails are definitely important and something PTC have been thinking hard about for the last 2-3 years.
Okay, great. Thanks, Roy. And we have one last question from the audience. How do you keep up to date with AI development? Is it closed off for security, or is the output the only secured access point?
Could you say that one again, Jonathan? I'm not sure I understood the context. Sorry.
How do you keep up to date with AI development if it is closed off for security, or is the output the only secured access point?
I'm wondering, do you think this relates to the large language model, Dave?
I'm assuming it does. Yeah, let's assume it does.
Yeah. Okay. Yeah. So I would say the systems integration aspects, the APIs, should be fairly standard. You know, we're looking to not just open up the APIs to the business system, but provide a description so MCP and the AI tools know that this particular function call, for example, is a where used query in a PLM system. How you train your own data over time, I think it depends how much of whether you're just using the LLM as a reasoning engine and a language understanding, or whether you actually want to embed your own domain-specific information in there. And I think there's more work on the latter for sure, but you would hope to see more accurate and relevant results from it by doing so.
Okay, great. And I'll just squeeze one more in because Lucas has asked a similar question, but asked differently. Will you come out with an engineer LMM, an LMM that somehow understands the mechanics of the world better than what is out there now?
Well, that's a good question.
It is a good question. Over time, I don't know, Lucas, but you know, I live in kind of the solutions consultant world at PTC, and we've been kind of waiting for this AI stuff to come out in our products and getting quite impatient. The reason PTC have been holding back a bit is because they've been thinking about all these aspects. So I'm not sure what's happening 2-3 years in the future. So initially it will be there'll be agents, essentially assistants embedded within the various tool sets hitting general LLM. But yeah, where we take this next will be interesting. But I can't give you a definite roadmap on that yet.
Stay tuned. Stay tuned, indeed. Yes, exactly. Well, David and Roy, I just want to thank you very much for the interesting insight of the work you're doing at PTC, and I encourage certainly Charlie and Lucas, who asked the questions, to reach out with David and Roy and vice versa on the event platform. But yeah, thank you once again, gentlemen, and we'll conclude this session and move on with the next.
Thanks for your time. Thank you very much.
Thank you.
Thanks, Jonathan.
Bye-bye.